Okay. All right. So this is a talk on, actually, it's really about flow, lean, and the theory of constraints, but it also will explain kind of why we use it. I really believe this lack of understanding or implementation or use of flow, lean, and the theory of constraints is the directly results in virtually every problem I see in product development. I mean, everyone. And we'll go through and see this. The reason for this is I'm not going to probably go into much, but it's like just laying science behind and trying to build model rockets without an understanding of propulsion. And I'm not speaking on speculation, I'm speaking on experience of having studied, well, I studied Toyota now for about 40 years. It wasn't called Lean at the time, but it was clearly an amazing company, and I was fortunate to come across someone who taught it to me. That's the best way to get business consultants is you find smart people who they kind of tell you what you need to know. I mean, it's funny, that's talked about a lot as not the way to do things, but you don't always know what you need to know. And in the 80s, I studied Toyota. So I've been doing lean a long time. Anyway, who I am, I know people here know me, but for anybody new, Al Shalley, I'm the CEO and founder of Success Engineering. Now, I've written a lot of books, and you can see some of them are technical. Some of them go back as far as Scrum. My more recent ones, The Lean Agile Way, was a collaboration with Gary Rupp, Richard Nestor, Steve, and myself. I don't put these up there to kind of say I'm any kind of authority because I don't believe in authorities. I believe in people who have experience and who have insights, and everything should be challenged. Um, and that's what I'm asking you to do. If you're watching this live, you can ask questions. Please do when you don't agree. And if you're listening to this, then there are different vehicles, including sending me emails when you have questions. Um, but everything I'm going to talk about today is something you have some past experience about in one way or another, and they're just collections of bodies of knowledge. So, what we're going to learn today is how we can use flow, lean theory constraints to efficiently navigate the complexities of knowledge work and understand systems thinking, which is mostly either ignored in the agile space, denied in the agile space. A lot of people have come up with complexity thinking, which I think holds us back, or is given lip service, but it's certainly not followed. Um, we want to focus on continuous learning, know where to look when something goes wrong, have confidence in our ability to improve our understanding and workflows. There's a lot of learned helplessness in the agile space, and much of it is old ideas that have actually been shown to be inaccurate. One of them is the iron triangle. The iron triangle was exposed as not a valid belief by Toyota. Oh my goodness, more than half a decade, I mean, more than half a century ago, over 50 years ago, they demonstrated the iron triangle is a limiting belief. You don't have to follow it, yet you still hear it talked about. We want to understand that complexity is mostly a problem in marketing. It is not a problem in product development. I know people think it is, but I'll talk about why it isn't. I'll talk about what our problems are. I'm not saying you can predict things out. For some reason, there's this uh, somebody says one thing on one end and says that's not true, and then they say, well, this other end isn't true. So, yeah, so we can't predict out. That doesn't mean that it's because of complexity that we can't predict it out. There are other factors. There is complexity, of course, in knowledge work, and that does make it so we can't predict things out, but it doesn't mean it's our major problem. I don't believe it is. In development, it's nonlinearity and cascading events. And I'm going to bring this up because what I'm going to be talking about with these things we're learning will give us a handle on how to avoid this. And that's very important. So it's not just learning what to do, it's also learning how to protect ourselves from the unknown that we can use. And that's just as important. So I'm going to go through these. I'm going to define flow, lean, theory constraints, and I'm going to show somewhat what the characteristics of they are, how they work together. So the best book on flow that I'm aware of is Don Reinertson's Principles of Product Development Flow, uh, back in 2009. And it's funny, you might notice the subtitle, Second Generation Lean Product Development, might give you an indication that he thinks flow is primary to lean. And in some ways it is. I'm not going to argue with Don, because anytime I have a conversation where we disagree, um, he turns out to be right. That doesn't mean I believe him either. It's why we have a conversation. But I did understand why flow in many ways is a senior concept in product management, product development to do things. And basically, it frames flow as the smooth movement of work through a development system. In other words, it's flowing, it's not held up. It means minimizing the time spent waiting in queues. Think about a stream that has swirling water. Well, it's kind of in a queue in a sense, it's not flowing down. Reducing variability that causes delays, making decisions based on the cost of the delay so that the most valuable work is completed soonest. It's discipline, work in process, feedback loop. So value reaches customers with the least total economic waste. He drives this whole process on economics of value delivery quickly. So that's a high view of flow. Lean, still my favorite book on lean for some reason. Uh, this is, I don't know, 20 years old, Womack and Jones. What I like about it a lot is that it's about thinking in lean, not studying Toyota. Toyota is a great company to study. I've studied it. Um, and it's about continuous learning and improvement with the aim of creating more value in less time and at less cost. It dissolves the iron triangle. They've shown this, by the way. In the 70s, they built cars at lower cost with more features and quicker turnaround to build them and design them. So we know it's possible. Now, that was in manufacturing of the building of it, but also the design of it. The Lexus was an example of product development using lean thinking to create a car that was more economical as a luxury car, ran more economically, and was environmentally friendly. They dissolved a lot of things that people believed you couldn't do. So the thing is, a general approach to lean is not specific to manufacturing. Lean thinking is based on the Toyota production system's thought process, but it's kind of like physics isn't about studying how apples fall from trees. It might have been where Isaac Newton got his ideas from. The same thing. Lean is not about Toyota anymore. Lean is the theory behind and some of the practices Toyota used, because we're not doing manufacturing. Well, maybe some of you are, but most of us aren't. Okay, the theory of constraints is brilliant, but it's somewhat misunderstood. Okay, it goes well beyond finding the constraint that bogs things down. He introduces the concept of inherent simplicity, which we'll talk about in the choice. Inherent simplicity holds that even in systems that look overwhelmingly complex, a small number of causes and effects determine overall performance. When you identify and manage these few leverage points, complexity becomes understandable and improvement becomes tractable. Rather than trying to optimize every detail, focusing on the system's true constraints predictably yield the greatest impact. The interesting thing about theory of constraints, it's decades old. And I had been observing, I've read several of his books, and I'd been observing what I would have called the arc of the theory of constraints, and it's changed its emphasis. And his daughter, who co-wrote one of his books and now kind of takes control of his writings and knowledge, says that theory of constraints where it is now is not where it was decades ago. Now, he's not obsoleted himself, he's just extended it, but it's just not about this constraint. There's a whole economics model he uses, throughput accounting, which I'm not going to go into. I'm not an expert in that. If you want someone who is an expert in that, you could talk to Wolfram Mueller or Steve Tendon. But I take advantage of it, and it's a very useful method. And I think the biggest value of it is this ability to look into a system and learn that it doesn't have to be this confusing system. Okay. So, and please do ask questions if I say things you don't agree with or understand. That'll make the talk better for anybody else who's observing. Okay, so I want to start with how they actually relate to each other and have things in common. Well, they all focus on value. So in some sense, they maybe do it differently, but that's a core. They do systems thinking. And they are all about learning and understanding. Now I'm going to go into systems thinking in just a second. But these three things are common to all three of them, again, doing it a little bit different. All three of these together is what is sometimes called the physics of flow. I'm not quite sure where that term came from. Wolfram Mueller is the person who told it to me first, and I like it. There is a set of laws underneath this. Now, some people kind of deny this. Well, they can. That's your choice, I suppose. Don Reinertson's book, which is held up to be an iconic book, describes 170 plus principles of flow. So there are a lot of people who believe that this theory actually can explain a lot of things. So let me talk before I get into systems thinking. I want to become clear about one of the big problems I see in our industry and in learning things. The first stage of knowledge to me is awareness. In other words, it's what do you know you don't know, maybe. Okay, well, I see it's there, I don't know it. We talk about there's what you know, there's what you don't know, there's what you don't know, you don't know. People leave out the fourth one. You know it, but you don't know you know it. That's kind of intuitive. And I think that these things can bring that out as well. But if we're not looking at what we need, excuse me, if we're not aware of what we need to solve our problems, we're really in a tough situation. So I like this I like this comment by Edgar Schein. We do not think and talk about what we see what we're able to think and talk about. And what he means by this is we filter out a lot of stuff. And if it's not in our consciousness, we don't even notice it. That gets filtered out. And we tend to look under the lamppost because the light's better, but that's not where we want to be looking. And systems thinking is something that gives us greater depth than just kind of reacting to things. And we must remember, I love this comment. These are my two favorite comments on one slide, which is a comfort zone has less to do with control and more to do with knowledge. Now, this works both ways. Sometimes I think about this as that's why managers get into command and control. They're comfortable with it, but they would be able to move out of it if they understood things better. And why do we stay in comfort zones? A lot of it is because we get afraid to move out of it because we don't know what the new movement will be. So when we understand lean theory, flow, theory of constraints, we can move out with more, what's the word? Safety, security, feeling better about things. So knowing this and studying this is very important. Okay. So I want to take a little stepping back on systems thinking because systems thinking is the cornerstone of all three of these. And it's unfortunate, like I say, I don't see our popular frameworks based on that. So Akoff talks about successful problem solving requires finding the right solution to the right problem. We fail more often because we solve the wrong problem than because we get the wrong solution to the right problem. This, by the way, also is why I'm such a big fan of jobs to be done thinking, because it gets us to look at what do the clients really need, not just what are they talking about. They're not just what they're talking about. Our ability to solve a problem is limited by our conception of what is feasible. Eliyahu Goldratt talks about that. If I don't believe there is a solution, real certainty, I will kind of stop. I will not keep trying because it's so much easier to pull back. This is where our learned helplessness comes in, because there's this denial of it, because people are saying, oh, it's complex and we can't see what's going on. Okay. You rarely improve an organization by improving the performance of one or more of its parts. The whole organization doesn't change it. That's what we do. So he uses this example about how systems are defined by the relationships between the components. In other words, you can see the car's got lots of components, but if you take the best parts of the best cars and put them together, you don't have a car, you have a pile of junk. So if we work on organizations, which we complain about being siloed, siloing has got two devils to it. One is, of course, the work doesn't flow well between the silos. But the other one is, even if the silos were perfect, it doesn't mean you're going to get a really good system because they may not interact with each other well. CARNAS, or effective product development, exists in the system as a whole. So systems thinking tells us a few things. And I would suggest, I'm not really sure where systems thinking originates, but Deming is the one who really put it together a lot in the management world. And he talks about systems thinking from the angle that it's not just how the system works, but there are a variety of tenets of, call it, of systems thinking. And you've probably heard this: a bad system will beat a good person every time. I'm going to just quickly review 5 aspects of systems thinking that on reflection, I think you can verify, or you could ask more questions. So first of all, you got to look at the whole. Okay, that's kind of obvious. You can improve one part, but that doesn't necessarily improve other parts. So you focus sometimes on sub-optimization, that won't improve things. It's usually a wasted effort. This is all, by the way, one reason why sometimes agile endeavors that start out with the team work against you. I've seen this where they say, hey, let's go agile, so let's get a scrum team going, and then the scrum team works great, but you've optimized the team. But often that happens by pulling the people you need for that team onto the team, and you remove those people's availability from other people. You've actually degraded the organization in some ways for the improvement of that team. And you haven't really solved the inter-team problems, which is the issue. So we need to look at the whole. That's the first thing with systems thinking. That's why one of the reasons it's called system. We look at the whole system. Okay. Again, it's more about the relationships between its components. I just said that. The system efficiency is determined by the efficiency of its components and their interactions. Of course, the components have to be good, but it's how they interact with each other. And a very interesting one is system behavior is determined by its design, intentional or otherwise. In other words, the behavior you get from a system is how the system is designed. Systems are often not designed either appropriately or even intentionally. So if you want to change the behavior you're getting, you have to change the way the system is. And this leads to, I think, a very important tenet, which is often forgotten. Look to the system when something goes wrong. Let's just reflect on this. If it's the system as a whole, and efficiency is defined by or determined by how things interact, and the system behavior is determined by its design, then that means most of our problems are due to the system, not the individual person in the system. I'll give you a quick example. Let's say you're a developer and your company is outsourced and offshored QA, or even code testing, and you're writing your code and you've got to wait 24 hours or a week to get any test run. That's going to adversely affect you. It's better to have test and code in the same team. Actually, it's best that developers write their tests and work and do it themselves, but that's another issue. But if you're missing certain capabilities available to you, then that's a problem. So when something goes wrong, we want to take the view that we're going to look at the system first. Now, I've said several things here that when you just reflect on them, I don't have a slide on it, but it's salient to me as I was talking about it. I mentioned learned helplessness. So we're going to see that by looking at the systems wrong, there's learned helplessness. But notice that if people get blamed when something goes wrong, when it's really the system, that's going to cause fear. And it comes that it doesn't matter what I do, I'm getting blamed for it. So that's going to cause people to pull back. And then people are going to try to encourage people to do things. This is one of the reasons Deming said, remove slogans. Don't tell people to work smarter, not harder, because it's not their fault that things are falling down. So part of the learned helplessness and part of the fear is due to this lack of systems thinking in the agile space. This also means instead of talking about individuals, we need to be talking about teams working. And instead of just teams, we need to be talking about the group. Okay. So how do they relate to each other? So we have, this is some other ways they're together. They all talk about small batch size because you can get feedback quicker, and it makes the system simpler to understand. Small items can be built in less time, and basically you can get feedback to um, course correct. Okay. Okay, I'm going to go through each of these now. I'm going to talk about lean, then flow, then theory of constraints. So lean was built on top of Deming's thinking. Deming had gone out to Japan after World War II at the bequest of General MacArthur, was the occupying general of the U.S. forces um, in Japan, and had to basically he brought Deming out because Deming had been involved in the war effort, the building of military equipment in the United States, and they needed radios. They didn't have good enough radios in Japan. So Deming was brought out, taught them how to do that. The Japanese companies noticed, hey, whatever this guy's doing, it's good thinking. Unfortunately, after World War II, this thinking was pretty much lost because he had trained mostly women managers, and when their men came back, they left the workforce and they lost this knowledge. So at one time we had Deming in our manufacturing area, and it was lost after World War II, but Japan picked it up, and Toyota noticed what Deming was doing. And Toyota was in an interesting situation. They had no ability to compete against the great American manufacturing companies at the time. Why? Because they could make better cars cheaper in high runs, high volume. They could do high volume runs, not Toyota, but like General Motors, Ford, whatever. So Toyota decided they had to go into niche marketing and niche markets and build small numbers of specialized cars. Okay. And when they did that, they found they needed to have quick turnaround time. So the just in time idea of just focusing, getting it done, they added that to Deming's work of looking at systems. And this had some interesting qualities that they were also aware of. It reduced delays in workflow, increased feedback, eliminated rework. Interestingly enough, the Toyota company actually had been in making cloth manufacturing, weaving, making, actually making the weaves, and they had learned that if you don't detect errors quickly, you will keep making errors. The ball, as it goes back and forth, if a thread breaks, it destroys the cloth. You have to undo all that. So they'd already had this idea of eliminating waste. So this idea of eliminating waste, lowering the time, were things they kind of added to Deming's work. You probably heard this: just in time and build quality in, stop the line when something goes wrong so you stop making errors. Okay. But here's the interesting thing. I want to step back to look at, to me, what the essence of of uh, of lean is in some regards. Um, how much of what you do is valuable and how much is waste? There's been this notion, eliminate waste, and like all this stuff, if it's not for the customer, is waste. And that is actually an incorrect view of things, in my opinion. In manufacturing, you figured out how to build it. So you don't have to discover what you're trying to build. You're trying to get the building process and reduce variation. In product development and knowledge work, it's varying. You're trying to figure out how to build it. And it's not waste spending time figuring it out. So like things like getting requirements, planning, design, this is all good stuff. Okay. And I think it's a mistake to call this waste just because it's not putting it in the hands of the customer. But these are clearly waste. This is rework. Okay. You'll notice I put fixing bugs in quotes because it's not actually the fix that takes the time. It's finding what you need to fix that takes the time. This is where automatic testing does good. It is where if you make an error and you can't figure out what went wrong, it could take you weeks to figure it out. The same thing with integration errors. Rarely do people integrate improperly. What they typically do is they integrate properly. The only problem is the integration agreements are wrong, and then things break. So the question is, what do we want to do? Can we go faster? Can we plan faster? Can we test faster? And the answer is, well, there are some things you can do about planning that I'm not going to go into. This is something we do in the Amplio learning journeys about how to set up planning using quickest valuable releases and some other concepts. And you can put in automatic testing, but no, not really. But notice how all of these are due to delays in the workflow. I want you to take a minute for that. Think about it. Redoing requirements is because you got them and then later you find out they're wrong. Or you got old requirements while you're now working on top of that. Building unneeded features. You didn't realize they weren't needed. So we're getting slow feedback. These are all little time bombs and waste going off, is the way I look at it. That's the problem. The question is, what percentage of your time is spent over here on this right side? In most companies, it's most of the time. So what they're trying to do is if you call this waste and this waste, when most of the time you're over here, you're wasting your time, ironically, looking over here. Look over here. And what's underneath all this is basically delay. This is one of the big insights of lean is it tells us delays in our workflow are really killers. So we've got to pay attention to that. Okay. How do we dissolve the iron triangle? Well, actually, Tom Gild and I have come up with this idea we call the penta because there are 5 pieces to it. We've got articles on it. I should add that as a reference. When I put this up on the website, I will. But I don't need to tell you how to do it. It's been done. In other words, I can't tell you how to create an airplane, but you know they exist, so it's possible. All I'm saying is the iron triangle is not true. Why? Because people have dissolved it. Toyota dissolved it. Now, it could be people have troubles doing what Toyota did, but that doesn't mean the iron triangle is true. It may be difficult. Actually, I don't think it is that difficult to dissolve the iron triangle. But the first thing you have to know is that it's possible to do that. So you to prove that by attending to quality, you lower waste, which drives down cost. And by driving down costs, you're spending less time working on useless stuff and you can add more features. Its quality is not a result of lean. Lean quality is the leading part of lean. You don't try to get time, scope, and cost under control. If you do that, quality probably will go down. You focus on quality. And by doing that, you get a result that makes a big difference. This quickens time of delivery as well. This is the general essence. Again, I'm trying to give an overview, not how you do all this stuff, but this is all talked about. Some of it's in public, some of it's in Amplio learning journeys. Okay, this is what enables you to have more features or scope in less time and at less cost. The key is to know it's possible. And anytime somebody is talking about the iron triangle, or in Agile, they invert the iron triangle. See, this is a problem. Inverting the iron triangle still is taking it as truth. There is no iron triangle. It's a made-up construct because people didn't understand how to get around it. Also, it comes from political science, not from product development in any event. The idea, and I'm just giving a little lip service to this, the idea is your level of understanding. You start with some level, and what you want to do is as you move forward, you do inspect and adapt, but you have to build your theories as you go. Lean is a theory, flow, and TLC. See, experience teaches nothing. You don't really improve with that experience. It's like playing whack-a-mole. Oh yeah, this, go for it. Hit them, hit them, hit them, hit them, hit them. When you have theory, you can understand why things are coming up. This to me is a damning statement about why there's so many problems in the agile space, because we're just having practices, inspecting and adapting. We're not improving our model. As we improve our model, as we understand more about how it goes, things get better. In other words, inspect and adapt gets you better based on what you know. But when you use plan, do, study, act, or observe, orient, decide, act, which is the OODA loop, I've integrated both of these in Amplio with what I call PDSA Turbo, which is basically PDSA and then using this to go deeper and faster when you want to, but it's an easy way. That you do better, you learn how to work within your knowledge, and then you increase your understanding. Learn how to do your knowledge, increase your understanding. That's what all 3 of these are. These are models of understanding. Okay, so let's get into flow. This is important. Cost of delay. Again, this book by Reinertsen is about the economics of product development. What is the cost of delay? What does he mean by this? Let's say I have something that when I get it delivered, it will be worth, say, $200,000 a month. And let's say I'm planning to get it done in 3 months. What if I get it done in 4 months? Well, that extra month cost me $200,000, not in building costs, but in less revenue costs, less opportunity costs, less in penetrating the marketing costs. So it's not just the cost of delay as the dollars lost, it's all of this market leadership I lost. What did that cost me? That could even be more. He found this, interestingly enough, I forget, I think he was working for McKinsey and Company, but it was some consulting company. He has an interesting background. I always like to look to see what the background of people are, because sometimes the background actually moves them along to discover things, and sometimes it holds them back, and sometimes it's constraining. But Don's background's quite interesting. He was the helmsman on a nuclear submarine. Now, as you might imagine, on nuclear submarines, they have a fair amount of workflow and process defined, because it's not a good day if one of those things blows up on you because you overheated the reactor. So there are lots of guidelines and things, but at the same time, you have to have the ability within those guidelines to make decisions, because otherwise it doesn't work well either, because they're kind of overly involved. So he had learned the value of systems thinking by being a helmsman in the Navy. And then he went to work for a consulting company. Don's a very smart guy. I've been blessed to know him personally and talk to him a lot. Very smart guy. So when he started being a consultant, what he decided to do is every engagement he was at, he looked to see why was it successful? What happened in the successful ones? And he looked at things like, did it have more features? Was it lower cost to build? Did I deliver it sooner? Different factors like that. And what he noticed was the cost wasn't that important. The number of features wasn't that important. It's what got out the door soonest was more important. Now, if you think about this, this is the essence of incremental delivery and agile. You build something, you get it out the door. You build something, you get it out the door. If it's the right thing, you can keep going. So it's the basis of incremental delivery, and it's also the basis of what we now call the lean startup and minimum viable products, things of that nature. So he noticed that the most important thing was reducing the cost of delay of delivery. So we want to focus on getting things out the door. By the way, this fits what I said about smaller pieces. And he said the way to do that is to manage queues. Work that's waiting slows down feedback. Feedback causes wasted effort and rework, which we get from lean. So we're already starting to see how lean and flow work together, because lean tells us just in time, and Reinertsen is telling us attend to flow. And we can see why this is important, because if we look at our common organizational structures, you have different groups, and our work, though, kind of cuts, we're organized this way, this top down, but our work flows across. And what happens is if we optimize this group and optimize this group and optimize this group and optimize this group, like we do in waterfall, we have big queues between the groups. We do all this analysis. Okay, great. But then now there's this huge amount of work. And Lean had seen this too, or Toyota had seen this too. When they came on board, when they were looking at how to do things, mass manufacturing was in play. In other words, if you had 5 pieces of equipment to build a car or whatever, you would get each one as efficient as possible. But what that would do is it would lower the per piece cost, and it would create a huge batch of inventory in front of the next machine. And if you had made a mistake, you had to rework all that stuff, and you wouldn't discover it until later. So if you look at manufacturing, mass manufacturing, you see that what you're doing is you're optimizing each of the pieces, which, remember, Russ Sakoff said not to do. You're actually creating a lot of wasted effort because you don't see that something's going wrong. And what Toyota did, not so much realizing it, maybe they did realize it, but it was forced into it. They had to run small batches because they were competing against a company that could do big batches. Even if the quality wasn't super high, they could sell it so much less expensive. So in the 50s and 60s, they could not compete and they had to come up with a small batch approach. So the thing is, what we find in most organizations, we don't have anybody managing the value, which is the work cutting across. They're just looking top down. Now, this is the interesting thing, and it's a good way to relate lean as we talk about it with time, or flow as we talk about it with time and Kanban. Time and queue size are related to each other. And I mention this because it's important to realize that there's a very big consistency here. In other words, if you're going to go to the airport, you might ask somebody, how long am I going to have to wait in line at security? Notice I asked how long in time. And they might answer, oh, not long at all. Don't worry, there are few people in line. You notice this every time you go to a grocery store, right? You see all the people waiting and you say, oh my goodness. You know, to go to Costco certain times of the day, and it's like, oh, I should have come early morning or midday or something because all these lines, although they've gotten a lot better actually. So queue size, and it's not just the number of people, because you go to a grocery store and you might see one line with 2 people, but each cart is totally jam-packed, and you see another size where, you know, you got 5 people, but they only have 2 or 3 items. So you have to pay attention to the total amount of work that has to go through there. By the way, this also opens the idea that maybe there's what's called classes of work. Like if you're TSA, these people go through this way, or class of work, like, well, they unfortunately don't have that. Or in the grocery store, items, 10 items or less. Remember, I don't see that as much anymore because they now have the self-checkout they're encouraging you to do. But it's the same idea, different types of work. So with flow, you can start getting more involved and more detailed about it. Okay. I want to pause for questions. Um, just give you a thought to absorb this, and I'm going to pick right back up. Take a breather. Tell me what questions you might have. We'll have some time, I think, at the end. I have a few minutes, but Frederick, actually, I'd like to ask. I saw in the chat you said should be interested to have concept agile in that model. Agile is not built off this stuff. That's the problem. I don't know if you want to talk about that. See, Agile does not believe, most Agile, especially the ones you put there. Kanban, to some extent, is built off of Lean, but not as much as it used to be. Dave Anderson and I formed Lean Kanban University back around 2010, and we had a variety of disagreements on pretty much everything. And one of them was the importance of Lean. You might notice Kanban University doesn't have Lean in its name anymore. And Kanban is quite good, but it doesn't have full lean thinking underneath it. It doesn't pay attention to value creation structures and teams and things. Safe and Scrum, even with a Kanban board, it's just putting a practice in. Kanban is actually almost the antithesis of a lot of this stuff, except for small batches. It's one of my bigger frustrations. I do like fast agile. I made a mistake. XP is quite interesting. Trying to think of his name, the industrial logic fellow, Joshua Karevsky. Years ago, he explained how XP and Lean were highly related to each other, and they are. XP is about really small increments with test-driven development. It's about paired programming and learning. But I would say Safe Scrum and the way Kanban's often done now is not particularly strongly related to Lean, and I think that's a shame. Okay, this is the big insight from theory of constraint to me. It's called inherent simplicity. So I had been struggling from about 2006 to 2019, where intuitively I would go into a place and I knew I could look at certain things. I could figure out what was going on. And I do mean that. People talk about complexity and you can't figure it out. I'm sorry, no. I wasn't alone. I'm not precognitive. I don't read minds. You know, I don't have out of body experiences. I've actually had an out of body experience, but not in a business where I go out of the body and I can see everything. That has never happened to me. That'd be nice, but it hasn't happened to me. And yet I could go in and virtually all the time I can see what they needed to do to fix things. And sometimes they did them, and sometimes I wasn't able to explain it enough. But it was pretty much right. And I was not alone at Net Objectives. I was CEO and founder of that. We had quite a few good consultants. I always rated myself as about the third or fourth best, which is good. I had people better than me, loved it. They could do this as well. The problem was getting it to explicit statement. And I couldn't do that until I read this book by Goldratt and his daughter called The Choice. And in there, he introduces this notion of inherent simplicity, that if we dive deep enough, we'll find there are very few elements at the base, the root causes, governing the whole system. And I've mentioned some of these. Do you have quick feedback? Are there delays in the workflow? Are you working beyond your capacity because that causes delays in the workflow? These are first principles. These cause delays. This is what's causing an effect. Now, it took me a while to realize that he did not say we see them all. We discover them as we go, but they are there. And knowing they're there means we're going to go out looking for them. Now, I've gone out and looked for them, and I've got articles and pages on this, so we can provide you with a solid base. In fact, flow, lean, theory of constraints, all of their principles are what he's talking about when you apply it to knowledge work. Now you have to be careful. He was talking in general. He's not. I'm not talking in general. I'm not talking about this is how you can solve world problems. No, that's a much more complex issue than where we are in product development. So we want to recognize complexity is not our problem in development. It just isn't. It's not our problem. Why? Because, well, let me tell you first what is our problem, and then I'll tell you how you solve the complexity. Complexity means there's some relationships out there that you don't see. This is another difference in viewing. It is true knowledge work is complex, but that doesn't mean all of it's complex. That means that there's complexity in there so we can't see the whole and predict it all, which means, remember, go back to Akoff's idea that systems are defined by the relationships. So some relationships are complex, meaning we can't understand them. They're not seen. But some are nonlinear. A nonlinear relationship is like the straw that broke the camel's back. He can put more straw on him, but at some point, the camel collapses. It's a break. Okay. Bridges tend to go this way. They can handle it, then somehow they can't, and then the whole thing breaks. But actually, bridges have another problem, which is cascading errors. If you look at how things like bridges fail, typically what it is, there's one stress point that all of a sudden it breaks. You had 1,000 pounds and now 1,001 pounds, and this piece breaks, but then breaks something else, and then breaks something else. In knowledge work, what we see is one person's not available who is needed at a meeting or not available to build something, and we get a misunderstanding, and an error occurs, another error occurs, another error occurs, another error occurs. And then there's work that if we had seen it, we could have stopped it, but we didn't see it. What's interesting, somebody once gave me this really good observation. Imagine the work this guy had to do to build the pyramid this way. So sometimes when we have a misunderstanding, we actually take more effort building something than if we'd built it right. Whereas the reason this is a funny cartoon is because you would obviously see things. But in knowledge work, if you're not actually getting the feedback, you can't tell just by looking at a developer typing. They look the same, whether they're writing bugs or not writing bugs. So this is not our problem. Now, another way to think this, I love this book by Clearfield and Tilsic, Meltdown. It's an anecdotal book. They give a lot of studies. It's where I also got turned on to 3 Mile Island and how normal accidents, which was the guy's study of complex systems. And what he talked about, or they talked about in this book, is that nonlinear, these big catastrophes that happen, they're due to a combination of a potentially non-linear event. In other words, it hasn't happened, but it could happen. In other words, there's a design flaw usually in the system, okay? And then it's coupled with other events that can cascade, like when the Titanic had brittle steel. It was had high sulfur content. They didn't know this at the time, that high sulfur content you need some sulfur in the steel, but high sulfur content makes it brittle in cold temperatures. They didn't know this at the time. So it wasn't the problem, it was a potential problem. But then what happened is one side got hit by the iceberg, or it kind of went along several of the watertight compartments. And then by one part getting flooded, it kind of then started flooding the others and it dragged the ship down. And well, here they kind of had visibility, but there was no way to fix the problem. In 3 Mile Island, part of what happened there is they didn't know what was going on. They had thought that the water level was at one level when it was really at another level because one of their design assumptions was mistaken and they didn't know a valve had failed. So in the real world, when something goes wrong, if you don't see it and you can't fix it, you're messed up. So this might tell you, is it possible to always fix the problem and get visibility and decouple things? See, think about this for a second. In the physical world, we're stuck. But in the product development world, we can build things in small stages so we can pivot. We can make things visible with testing, automatic testing, getting feedback. We can decouple steps. So if one thing happens, some other bad things happen. And we don't know about the nonlinear events, but then we're protecting ourselves. And this is actually why complexity isn't the big problem a lot of people in the agile space claim it is. Because we take advantage of what we know from these other approaches. And this is why I kind of get upset sometimes, is because people are saying, oh, you can't do this with complexity. I'm saying, well, no, you're denying what's you need to do this with complexity. And this is why there's so much problems right now. Okay. Questions on this? This is actually really big right here. This is a big, important thing to know. It goes to the belief of, are there these axioms that you can understand? Okay, so finally on here, in theory of constraints, well, yes, attend to the constraint, but constraints are not always blockages in the system. See, this is the problem. It's not the theory of blockages. It's the theory of constraints. For example, a constraint in a development environment could be that there's no intake process. Work just comes in and goes straight to the team. So nobody knows what's going on. Nobody knows how to work with each other. Nobody knows who's needed for somebody else. The constraint is something that's missing, actually. Very often the constraints show up in the workflow itself, but it doesn't have to be. So there's a difference between a blockage and a constraint. And you look for the constraint. Now, the thing that's interesting about this, I've talked about inherent simplicity and focus on the constraint. So before I say how these all work together, let me talk about complexity is a problem. No, actually, I think I'm going to talk about this. Notice the three of these give us different things to look at. Lean tells us to look at the whole, attend to time, be aware of systems thinking. They all tell us to look at value, system thinking, and learning. So the way you use these three together is, while they all focus on this, but then this has more insights on just in time and how to continuously learn. The Toyota Kata is a method for that, incremental learning based on the science that's underneath here. Here we're going to manage queues. We're going to attend to the delay of value. We're going to look for constraints. We have this understanding of inherent simplicity. All this creates what we call the physics of flow. And they all work together. There's nothing contradictory here. I like all three of them. Okay. I didn't want to say complexity is not a problem. It definitely is a problem in marketing. So what we want to do is create visibility, requires quick delivery of value to challenge our assumptions. This is where the minimum viable product comes from Eric Ries. This is a brilliant book. When you read this book, at least when I read this book. So the startup, the lean way, Eric Ries's other book, the lean startup. What was brilliant about that is he really projects lean well. But in this, he's saying the startup way, how do you continuously improve and be entrepreneurs, big companies? How do they create new products? And the interesting thing about this book when I read it is he's really about challenging the assumptions. And then you could use flow, lean, and the theory of constraints to pivot when your assumptions turn out to be false. So he doesn't talk so much about all this stuff I've talked about, but it's a brilliant book because it's about challenging assumptions. And you do that by delivering small bits of value to people to justify, not to justify, but to see whether you're right or not. This is where, if you read a lot of stories about new companies or new products, that's exactly what they did. They were just trying to see what's is this right? Is there a market here? And then you don't need to build the product in a fully blown out way. One of the interesting things that they use in the startup way is GE's new engine that they had for a particular niche. And normally GE would never have built this engine because it would have taken too much getting it supported and improving there was a market. So the people in who wanted to build the engine for GE got it. They were, look, let's just get it out there and see if it's a market, and then we could put in the rest of the things we need to do our full support and things. And it worked. They validated their assumptions and it was a success. The biggest thing I think these is we learn better. The model of understanding enables taking advantage of what people already know. One of my least favorite things to hear is follow to understand, because when you say that, you get resistance. Well, I want to understand. I mean, some people do want to follow, but a lot of people don't want to be told what to do, which is kind of ironic. We say that's the advantage of agiles. Don't tell them what to do, but oh, by the way, when you start, you have to do what I say. Follow until you understand it. And the reality is, people can use their past experience. You know what multitasking is like. You know what, or more accurately called task switching. You know what delays, putting something down and then coming back to it weeks later is like. You shouldn't have to follow to understand. You should go back and get people's latent knowledge. This is what they knew, but they didn't know they knew it. This takes much faster learning. And Toyota, the Toyota Kata by Mike Rother is a really brilliant book. This is an integral part of the Amplio learning systems. Is I kind of extend it a little bit, as I tend to do, both using it for mentoring, coaching, and training. But it gives you a well-defined way of learning in small steps. Teach them what they already almost know. This is really brilliant stuff. Now, where can we go with this? There's a lot of places to go. It's good to learn more about value stream analysis. It's good to what I call the factors for effective value streams. I took inherent simplicity and I said, okay, well, what can I do to, when I'm in a situation, how can I see to improve the workflow? So one of the factors for effective value streams is try to avoid handoffs. So you have to look at what improves reducing handoffs. So when you take this first principles, when you take this theory, you can actually use it to see, oh, how do I guide things? Shorter increments. I've been doing in Scrum, before I was even doing Kanban, we were doing 1 and 2 week sprints. Why? Because we knew that would make things more effective. And I'm going to make a strong assertion here that I've got evidence for. Virtually every company I've gone into, or every team I've gone into, I'm going to talk about team for a minute. When they're having troubles, it's because they're violating some lean principle or theory constraint principle or flow principle. And they're not aware of it. They just say, oh, the world's complex. I can't understand. That's learned helplessness. Very frustrating to me. We need to create diagnoses. You ever gone into a doctor and they say, oh, you need this done? And they didn't even look at you? Now, there are reasons that Scrum and SAFe don't believe in diagnosis. I wrote a post on that, but part of it is because they don't have this underlying philosophy, this underlying understanding of physics of flow. It enables learning together because we have this joint model of understanding. An ability to use effective practices in our context, much more effective. The practices become more effective, and we don't have to rediscover and reinvent. I know this sounds cynical, but I don't think it was done consciously. I don't think so. I know a lot of the thought leaders in other areas, and I don't think they're malicious, and I don't think they're trying to bilk anybody. But the reality is our agile space is set up so you have to learn a lot more and do a lot more to make things effective because you're ignoring this underlying foundation that's available, and it requires more training and more coaching than is necessary. I mean, an order of magnitude more. What I find most interesting about this thing, I did a seminar yesterday, and I got one out there. I'll do another one on the what I call jobs to be done thinking. Is it's enabling a connection from the very beginning of the value stream to the end of the value stream, and it covers a lot more territory, but it's simpler to teach. Why? Because it uses consistent pieces that all tie together. Instead of having this component of a system like SAFe does. SAFe's got like 20 different separate things that kind of tie into each other. This is a continual flow from one end to the other. And it makes it simpler because it focuses on the relationships of the different stages of work. Okay. Almost every problem, and I do mean almost every, I mean like 95%. Oh, I just hit that. That's funny. That's the number Deming talks about as being the result of the system. Uh, is because they're not working on a foundation of the physics of flow. Okay, well, a little less time than I'd hoped for question and answer, but I'm done with the presentation. I'm going to put this up here because this is how I teach this now in a new way. We have 2 sessions a week. I take 1 session a week for a particular topic. Right now I'm doing advanced product management. It did start a couple of weeks ago, but there's recording. This is revolutionary. In the 80s, I was building software where I did not have to rework a lot, and using jobs to be done thinking as I do here, you can it's also possible. It's again one of the learned helplessness that we can overcome. So anyway, I'm done. Questions, either about the program or about anything I've done. Well, if you don't have any questions, I guess we can just call it an end. Is it that clear, or are there areas you wish I'd gone deeper? That's also good. Tell me where you'd like me to go deeper, because I can do that in another talk. Going to show you what's coming up. And then I'll close the talk. Next week, see, I'd push this talk back a week. So normally we do these every other week, but it's just 1 week. I'm going to talk about design for non-techies. There's a lot of stuff coaches should know that they don't need to be programmers for. And then 2 weeks after that, I'm going to talk about, I'm going to give a demonstration of how we don't really see things we should, because we're not talking about it. Okay, well, thanks for being here. I'm going to post this up on the website. If you have questions, feel free to contact me, al.shalloway@successengineering.works. Thanks.